Thank you. Okay, so everyone can hear me and everyone can see my screen now. Set up. Perfect. Okay, so in today's lecture, I want to go ahead and try to pick up where we last left off with React. So on React, we introduced the idea of how we could define functional components. And by functional components, I mean that when we define our React components, we declare them as functions that return back some JSX element. And JSX elements are HTML-like syntax. And so this allows us a programmatic way to design our graphic user interfaces inside of the DOM, inside of the browser. So a very powerful way to start being able to create very complex interfaces in a way that is akin to the way we design our backend applications. We could start breaking it apart in terms of object-like structures. Okay, so what I want to pick up on in terms of these functional components is this concept of hooks. And so hooks will allow us to be able to essentially have the concept of state inside of these functional components. And so what we're going to do here in terms of functional components and hooks, we'll define what are hooks, we'll talk about state and useState, and then we'll talk about state and useEffect. Excuse me. Okay, so what are hooks? Hooks provide the full capabilities of React in a more functional programming approach. So we're going to look at how to use React in an object-oriented approach, and I decided to show that last. I think that'll make a lot of sense for those of you who are already familiar with an object-oriented approach, but I decided to initially start with a more functional programming approach. And for those of you who haven't taken programming language structures yet, functional programming is just another paradigm by which we could design our code base. And it's one that differs slightly from an object-oriented approach, whereas objects, we define classes that we can instantiate off of, and these classes can maintain some sort of state. Typically, in a functional paradigm, you create your software system as a collection of stateless functions. And so the function relies on data that's passed into it and produces output. And then you could string these functions together to do whatever data processing needs you have. And so the idea behind a functional programming paradigm is you try to remove the concept of state across all of your entities in the software system as much as possible. Now, obviously, you might not be able to remove like all your state, but you try to consolidate where that state exists at. And so that way you don't have to worry about dangling states existing in every little instance of your software system like you might have in an object-oriented approach. So it's just a different design philosophy for creating software. And so we're going to examine this style here. And so one of the difficulties with a functional approach is, again, well, where do you get your state from? What happens if the state can't come from the parameter list of a function? And that's exactly what hooks allow us to do, is to go ahead and have ongoing state in something that is essentially a function. So hooks are just an alternative to the JavaScript classes to be able to write these fully fledged React components. So why might we want to use hooks? Well, it allows React to encapsulate properties into a function. So the functions become they have more abilities to be class-like, but at the same time, still technically maintaining a statelessness. The concept of a component that does not depend on anything else corresponds with the functional approach. And that's what we kind of philosophically target when we're talking about these React components. The motivation behind a React component is that it's supposed to be a stateless a GUI element that you just send data to, and then it displays that into your view. And so the output being dependent on the inputs of the function. And then the abstraction of a function is pretty elegant in the context of how we want our React components to exist. So why hooks? Well, functional components already did exist in React even before hooks, so we could always have expressed our components as either classes or functions. However, they were extraordinarily limited until the most recent release of React. So now you can accept properties and render HTML based on those properties. They couldn't tie into some of the more fundamental and advanced features. And so again, hooks allow you to essentially have states or be able to do or be able to examine the life cycle of your React component, which we'll talk about a little bit later. But essentially, hooks allow functional components to have parity, complete parity with class components. And again, the reason why I start with functional components is that in the newest release, I believe that the React team said that they're going to continually have the class components as part of the spec, but they're not going to advance that portion of the library any longer. So it looks like they're targeting hooks to be kind of the future of where the React library is going. So it's an important concept to know. So let's start with a basic example of how we might use the useState to be able to have a continuous state inside of a function. So the first thing we would look at here is we will have our import statement. So we're going to import React, and then from the React export, there's also a method that's called useState. We're going to want to go ahead and grab that too, destructure that, and let's suppose that we create this this functional component called example. Inside of example, what I can do is I can use this useState function, and I can pass in the parameter what I want to initialize that value of whatever the state-like entity, think variable, is going to be. So I'm going to then destructure from useState the stateful thing I want. So suppose inside this example, I want to keep a count of something, and then the ability to mutate this state. So I will have count and set count, and set count just allows me to mutate the state of count, and count will be initialized with whatever gets passed into this parameter of useState, so it will be 0. So now inside of my return, where I return my JSX, I will have a div. Remember, I need to have one root element and any number of nested children. I will have a paragraph element. I can dereference the value of count here when I use the state. So initially it should be 0 times. And now notice I'm creating the button that has a click event. So on click, and notice when I create an on click event on the button, I again use the curly braces to be able to embed into my JSX true vanilla JavaScript. And I'm creating the callback function here that whenever this button is clicked, it will invoke the setCount method to update the state of count to have whatever the current state of count is and add 1 to it. Now, one thing about the setCount method is it not only mutates the state of count, but it will also, whenever it's invoked, it causes the functional component to re-render that component inside of our view. So when I click that, it will not only mutate the state of count, but then it'll also go ahead and redisplay that. Okay. So let's see here. Let's test this out. Now I'm not running my camera. I think one reason why my computer gets so laggy is with the Zoom camera. So let's see if I can do some code testing here. So if I'm going to do some code testing, let me grab this so to be able to get into my Codepen instance. Okay, so let's jump into Codepen. So recall I had this Codepen example last time where I configured this, and I think I showed you that on how to do that last video in case you want to test this out without installing React on your local machine. And so here, what I will do is I will replace this. So let's go here, and I'm going to need that. Yeah, okay. Need that. Okay, so I think for this example, let me get rid of this from my example. So I'm going to use the state. Let me go back to that sample code. And hopefully I can run this without freezing up. Okay, so let's see. This is example. So let me go here. Okay, so I now have my example component. I am importing useState. I'm not using useEffect yet, but I'll import it anyway. So on my element here, instead of this hello, let me instead go ahead and just do the example component. And so now, because I put the example component in there and then tell React DOM to go ahead and render this element, which is my example component, I now have you click 0 times. And to prove that we can now have an ongoing state inside this function, when I click, it now becomes 1 time, 2 times, 3 times, 4 times, 5 times. Excellent. So now you actually get to see what this code is doing in practice. Is there any questions? Does this make sense to everybody, this concept of how we're able to go ahead and manage state inside this function? Using this useState method that's part of the React library. And again, this is what's called a hook. This allows us to hook in and define a state and access that state each time we need to manage inside of our component to be able to render something. Okay, for demo purposes, I'll just put the slide in for me to be able to easily cut and paste. Okay, so the useState example, well, useState is a hook. The useState function returns 2 elements, a current state value, and a function that enables you to update it. The initial value of the state is the thing we pass into the parameter. So it doesn't have to be the number 0. It could be like empty array. It could be an empty object or dictionary. It could be just null object if we wanted to. It could be a false statement if it's supposed to be Boolean. So like, just understand this parameter is whatever you want this variable to be initialized as. And then the idea is that throughout the course of your component function, you or your function component, you would mutate the state in some kind of way, and that would cause it to re-render. Okay, so now what really is a state? Well, hooks is a hook. Hooks are functions that allow you to hook into React features like state and what's called the life cycle features from the function components. And an example of a life cycle feature is the ability to execute code when the component is either first created or to be able to execute code when the component updates. So what is state in React? Well, state is just a variable. It's a single piece of data that resides within a component. And each instance of the component can remember its own state. So it allows us, again, for our functions to become very object-like. So again, the idea is to get functional components to be in parity with class components, which we will also cover. And so, and then what's nice is you can mix and match the two. So you can use either of these approaches inside of your React code base, whether you want to use a class component or a function component. And then when a state variable is changed, React re-renders the component, incorporating any changes, as we saw when we did the push button example. And so this is just looking back at that same example, but I think that we described it pretty well, so I will move on. And so we already described what is happening there. Okay, so before I move on to the useEffect hook, is everyone fine with the useState hook? Just for the most part, you see how you get a more object-like functionality on your functions, on your component functions with that? Or is there any questions up to this point? Well, with the useEffect hook, it gives us the access to what's called the React lifecycle features. Lifecycle features, in this case, just means it's access to special times either during the creation or during the update or operations of, or of the removal of a component. Those are, and so useEffect takes one function, so it takes in as a parameter a function, so it's a high order function that will be executed right after the component is rendered to the screen. So in effect, the hook gives you the ability to run code on startup, and when any state changes in the component, or when the component is removed. So it allows us to essentially trigger the invocation of a callback function. That's effectively what useEffect means, is that during one point in the life cycle of your component, you can cause a function to trigger. And so this is super important for instances typically when we need to fetch data from a web service. We don't want to constantly be fetching that during the runtime of our component, so we can implement the fetching inside of the useEffect call and be able to do it that way. So let's take a look at this example. So suppose we create this useEffect, and again, this useEffect is taking in a callback function that's here. So this callback function, just a fat arrow function, where we're going to go ahead and do some kind of subscribe method. So we're going to subscribe, and then on return, when the function is when the component is destroyed, it will unsubscribe. So again, just to give a good detailed examination of what's happening inside this useEffect, we are invoking, or we're passing that callback function. So useEffect here is pass a function that contains two statements. That first is subscribing to whatever the property source subscribe is, right? It's just an example code that can't actually run, just proof of concept. This will be done anytime this component is rendered to the screen. So anytime the component is re-rendered, it's going to do this first statement. This one right here. Second, if the component is removed, then the function that is returned will execute. And so the return statement, notice, is a callback function for when the function is destroyed or removed. And that's where we perform our unsubscribe operation. Okay, so with that said, why don't we look at how we might use the useState and useEffect so that we can trigger a function to fetch data from some remote service and store that data inside of our function so that it can maintain that state. So if I wanted to do this, then I would go ahead and I would import both the useState and the useEffect methods from the React library, in addition to React and the React DOM for rendering purposes, because this is all going to be one giant script. Inside of my function component that's called weather, I can receive properties. So remember, those properties come into the function via JSX, and they look like HTML attributes. I'm going to invoke the useState method and initialize temp. So I'm going to have a temp variable and the ability to set that temp variable. So, and the initial value of temp is going to be set to 0. So clearly we're going to do something weather related that's going to have a temperature. I'm going to create a function inside of my component that's called getWeatherData. It's asynchronous. This is doing a fetch to some service, so some REST API to get the weather data. If the response was not okay, then I'll throw an error that I got some kind of error code. Otherwise, I will get the JSON that came from the response and return that. Okay, so now that we know what this function does, let's look at this. So inside of our useEffect, so this is going to be we're going to trigger some behavior during the life cycle of our component via a callback function. So we're going to define a callback function. Inside this callback function, we're going to invoke this getWeatherData method that we just declared. So again, this is an asynchronous method. So when we initially go ahead and create this component, and so remember, useEffect will happen whenever we render our component. A component initially renders when it's created. So when this is first created, we will fetch that data. Then we'll go ahead and use the then notation instead of the await notation. Doesn't matter which ones you use. We use both, but each can be appropriately used here. But after we get the data back, we will then invoke a then, which will trigger this callback function, which we will take the response that gets returned from getWeatherData, And we will invoke the setTemp with, from our response is a main property, and inside the main property is a temp. And we'll actually look at this to actually prove this concept. And then if an exception occurred, then we would just catch that exception and display to the console. But what this should do is this will call the setTemp that we got from useState and actually mutate the state of temp from 0 to be whatever the temperature is that we just fetched. Then inside of the actual return port of our function component, we actually return JSX. The JSX we return has to have a root element, so that's going to be a div. Inside of our div, we will just create text that is strong, that's bolded, that will dereference the property location, so the location from our props. That's being passed in. Now remember, props is the thing that's passed into the function. It's like from the parameter list. And then we'll dereference the value of temperature. So let's go over here then and see inside of our then app function where we can get some set of properties. We will just return in our JSX, the div, and then we will actually create 2 weather instances. So again, in JSX, it looks like HTML elements. So we will create a weather element and we will pass it by its properties, what looks like an HTML attribute. For the location, we will send it Berkeley, and for the location, we will send in Concord. And so when we go back here, when we look at the props, those are going to be the props that are passed in here, Berkeley or Concord. And so that is what would be used to go ahead and do this fetch. If you look at this fetch here, it might be hard to read, but you're seeing I'm doing the props location here. And so that props location is coming from the parameter list of this component function. Excellent. And so we can actually see this code in action. So let me grab this. So let me get this function component and let me go into here and let me, and actually I think this has everything I need. So I should be able to remove everything except for those imports. So let me get that function component. And now let me go back to my source code here and grab this function component. And let's see here. And there we go. And so you saw initially that the temperature of those 2 started at 0. And then when the fetch was completed, it did a set state, and that set state calls an update. So did you see, did everyone see in just after an initial moment, it was maybe less than a second, it went from 0 to actually display the readouts here. And presumably, excellent. Okay. And so here was a giant example that showed us how we could use Effect to be able to do API calls and how we can go ahead and use state to change the state of data that's maintained inside of our function, which 2 very valuable things you might need to do when maintaining some kind of interface component or a React component. Okay, so note we are using both useState to keep the state of the temperature and useEffect to make an API call to the weather endpoint to get the weather. The function in useEffect is actually is used on every render, but since we only pass a property of the current location, it only needs to be rendered once. Excellent. Okay, so now that we understand what React hooks are, and we've learned how to go ahead and be able to maintain a state in a component function and be able to trigger things like fetches during the lifecycle of a component function, there's also the ability inside these functional components to be able to define a custom hook. So let's look at that. So this will be a very brief set of slides where we'll just talk about the rules of hooks and then show examples of a custom hook. And then I want to just briefly go over class hooks. I mean, class components in React, so that you know the two distinguishing ways we could do this. So rules of hooks, you must use hooks in functional React components. You must use hooks at the top level of your component. So that's the first thing. You can only use hooks in functional React components. You would use instance variables inside of React class components. So hooks are to compensate for a lack of instance variables in a function. You must use hooks at the top level of your components or in your custom hooks. This means don't use hooks inside conditionals. And this is because React relies actually on the order of the hooks to determine your functionality. If the order of the hooks is executed dynamically during execution, it can create erroneous behavior or bugs or things like that. So React does provide the ability for us to write our own hooks. Custom hooks can provide another way to share stateful logic across components. So we already talked about what stateful logic is. Let's see here. Okay, so as your front-end application becomes more complex, it obviously becomes harder to maintain all the state variables, as well as all the logic that modifies the state variables. What happens when you want to have some state that affects multiple components? Then React has provided a few ways of accomplishing this task. But typically, it involves creating more components that contain the shared state at a higher level. And hooks provide an alternative path to that, as opposed to these higher order components. So remember that each function would typically maintain its own state. So you would have to use the useState in each function that requires a state, but it could be common that multiple components might use the same state. So in those instances, we might need to define our own custom hook so that we can adhere to the dry principles. But to motivate this concept, why don't we look at a sample code that will have some duplication in what's happening between functional components, and we can see how we can define a custom hook to make this easier for us, or to make our code base look much better. So let's look at this. This is, again, just setup code. It's not designed for something that can actually be run. Think of it as something that's part of a larger software system. Let's take a look at what it actually does. So here I'm going to import React, and then I'm going to import the useState and the useEffect methods inside React. Inside of here, I'm going to create a functional component that's called friend status. It's going to take in some amount of properties, which would be attributes for the JSX syntax. Inside here for useState, I'm going to initialize the state to be null for what's called isOnline. And then we also have the setter method for isOnline. For the useEffect, we're going to pass a callback function. The callback function is here. So the callback function is essentially going to go ahead and have a callback function for when we initially render, and then it's going to have a return callback function for when this functional component is removed or destroyed. So on this initial callback function, when we instantiate the functional component, it's going to be called handle status change. Given some status, it will set isOnline to be whatever the status is that's been passed in. So we're invoking this set, and that will cause a re-render by causing this set method. And then what we will do is inside the chat API, we will subscribe for friend status based off of these parameters. So this is just an API call with this new change that we just made. And then on a return, when we go ahead and close out the application, then we will unsubscribe from that friend status. So this essentially does the cleanup work. And then in our return method, it's going to isOnline. It's going to check to see if this is true or false. If it is, it's just going to return back the string online or offline. Okay, so clearly this is just doing something to check to see if someone's online or offline. And so here we have a component called friend status that is called online if the friend was online, and offline if not. Note the use of the useEffect hook is defined what should happen when the component is initially created or updated, and what should happen when it unsubscribes. So up to this point, does this sample code make sense? Okay. So imagine if we had another component, such as a contact list, where we wanted to highlight a person's name if they were online. We would write out the logic, but it would require repeating a lot of the same code. Let's see what that looks like. So let's see, this would be the new code, and let's see how much of it is similar. We import React. We're going to use state and use effect. So clearly we have to use this. That's going to be pretty similar, but that doesn't really violate the dry principle. Let's actually look at the functional component. So we're going to create a functional component called friend list item, which receives props. We're going to create our state in here, is online, set is online, right? Same state, initialized to null. We're going to define a useEffect method, pass in a behavior here, handle status change. This is the exact same that we have to do in our useEffect, right? So we initially have to get the status and toggle the status to be online if we want to highlight the friend. And then inside the chat API where we're subscribing to friend status, we're going to pass in those parameters, and then we'll do a, on return, we will then unsubscribe. So notice this useEffect and this useState is the same on friend status as it is on friend list item, right? The only difference is inside the return method, right? We're returning it online or offline for this component, whereas this component, we're returning a list item where we're going to style the color based off of green or black, whether they're online or not. So in this instance, when you start finding that you're repeating similar blocks of code inside your components, this is an instance where you might want to consider defining a custom hook instead. So here we want to do a status, yeah, friendless. Okay, so here we want to refactor. We want to adhere to the dry principle. We want to put common code into a function and use the function instead. And the benefits always include what you've already learned about the dry principle. Not repeating code can be error prone. Once you update the behavior for the shared function, it's available everywhere, and it's much easier to read when you start breaking your code up and only have one source of truth or one place where a set of similar statements exist at. So let's look at a custom hook. So here we will import useState and useEffect from React. We will create a function. So notice here, this is a hook. It's designed to be something like useState and useEffect. This is not a functional component. Hence, it does not have an uppercase letter. And we start our custom hooks with the same labeling, with the same naming, with the term use, just like you would have useState and useEffect. So hooks typically preface or prefix with the term use. That's just a convention thing. So here, our custom hook will be use friend status. And here, the thing that we will pass in will be a friend ID. So then, inside of this custom hook, it will be the thing that uses the state and initializes it to null and will create as is online or set is online inside of the function, so that this function, even though it's not a component function, the hooks allow any function to be able to maintain state. So this function can maintain the state of is online, and then any function can have the useEffect. So even though we're not using it as a functional component per se, we still have the ability to use the effect from React to create a custom hook and then give it the callback function, which is the exact same code that we were using in the other functional components. And then effectively what we're returning back from here is, instead of JSX, because again, this isn't designed to be a React component, it's actually returning the state of is online. So here you can evoke this function and give them some friend ID. You can find out if that friend is online or not. And so the amazing thing is that custom hooks is also just another function with inputs, outputs, and logic. You can use other hooks inside of a custom hook. You're writing a stateful logic that can be shared across components, and you can also fully control the inputs and outputs of your hook. In this case, we can pass a friend ID and return whether that friend is online. So let's look at the refactored code with the custom hooks and the sample code that we initially gave. And it's going to look at how much easier it is to read with this refactor with using a custom hook. So the function friend status with some props. Now we will set is online to be the result of use friend status and passing from our properties the friend ID. If is online is null, then we'll just put loading, but otherwise we will return the same thing we were returning before because we have that state. And so similar here, instead of using the useState and useEffect, we will use that custom hook, pass in from our properties the friend ID, and then we could just return our JSX of the list item and decide whether we do green or black based off that result. And so that is custom hooks. And so you can see how custom hooks allows us to start creating shared data or stateful data that can be accessed from multiple components. And so with that said, I think for the most part, that is all I have to teach about functional components in React.